When there's a big inflammatory response in the body, even if it's not happening in one area of the body, it can affect another area of the body. So we see this all the time. And one area that gets affected is the bone marrow. So for example, if you get sepsis from pneumonia in the lungs, you will have a significant leukocytosis and production of leukocytes from the bone marrow. So most people that work in hospitals know that because they see a CBC and they see a high white blood cell count. But what they may not realize is that other things are happening in the bone marrow. So erythroid precursors, the precursors to red blood cells, have decreased responsiveness to erythropoietin. So inflammation impairs the response of erythrocyte precursors to erythropoietin. In fact, it's even a little bit more interesting than that because there are subgroups of patients with systemic inflammation that have decreased levels, meaning they're making less serum erythropoietin as well. So that can be a double whammy. Not only are you not making enough erythropoietin, but in the bone marrow, your red blood cell precursors are not as responsive to erythropoietin. So it's always interesting, humans have 206 bones when they are adults. And I always say that us German Shepherd owners, and boy, do I love German Shepherds, but we think they love us for our personalities, but I think they are just waiting. I think they know more than 200 bones exist in our bodies. Getting back to erythrocytes, our red blood cells, not only are we not making them as well in high inflammatory states, but when there is a lot of inflammation, our erythrocytes survive for less time. In fact, they can survive 25% less days, so only 90 days instead of our usual 120 days when there is a lot of inflammation. One of many reasons for this is macrophage activation, and so this is often termed a consumptive anemia of inflammation, in which there's hemophagocytosis. But this gets me back to what I was saying in the part 1 series about anemia of inflammation, that you may understand certain lab levels better if you understand the disease process. So many of you know that ferritin is an acute phase reactant. And in fact, we also know that serum ferritin is low in iron deficiency, but it's often high in inflammatory states. Now, while most of you know that ferritin is an acute phase reactant and is high in inflammation, can you say why that is? And there's probably a few reasons, but one of the main reasons is that macrophages are indeed a main source of serum ferritin. So macrophages are activated in acute inflammation. Macrophages, again, are a type of a white blood cell. So we increase our white blood cells often in acute inflammation because macrophages go on to eat things, foreign substances like microbes, cancer cells, and then they also destroy red blood cells. Macrophages play a key role in destroying older red blood cells, usually at 120 days when things are working well, and the erythrocytes usually have a lifespan of 120 days, but sometimes when they're activated, they remove red blood cells early. Now, I also mentioned in the first episode that hepcidin has some unique properties, including being increased in inflammatory states, but one thing I didn't tell you in the first episode is that in addition to hepcidin decreasing iron absorption from the small intestine, it also decreases the release of iron from macrophages, again, decreasing the amount of iron in the plasma. I know, it's a little hard to remember all this stuff. I'm just trying to remember what happens when iron combines with oxygen, but my brain is becoming a little bit rusty, so forgive me. Though a point probably worth remembering is that when mature erythrocytes, when mature red blood cells don't have access to iron in the plasma, they also have a hard time surviving for as long as they want to survive. Things sometimes die prematurely. I always thought it would be ironic if Marvel killed off Iron Man prematurely with anemia. It probably wouldn't make for the best superhero movie, but think about it. They did kill him with a disease that causes anemia, like colon cancer. That would be the ultimate teaching moment, where Tony Stark can then explain why skipping screening for colon cancer can even take down an Avenger. I will add that to my list as to why I've not been hired as a screenwriter in Hollywood, but there's still hope. They will hire any comic nerd to write for those movies, but they will not hire science nerds, because we would always do things like have Silver Surfer and Iron Man be together fighting because they would be great alloys. Well, they should probably just stick with their usual writers, because if someone like me wrote it, the scenes of Iron Man becoming more fatigued and tired as the anemia kicked in, that would be challenging for a lot of people to sit through. But it does bring up an important point in anemia of inflammation, which is something called the Lifelines trial. So this was published in March of 2019 in the journal Hematologica. And while some of the trial was obvious, which we all could have predicted, that having a lower health-related quality of life was present when you had anemia, what wasn't so obvious is if you particularly had anemia of inflammation, that subgroup of anemia not only had a decreased health-related quality of life, but a worse overall survival. Now, the question then becomes, which this study could not answer, is the anemia just a marker of worse outcomes, of adverse outcomes to happen, or does the anemia itself contribute to that worsening survival? If we develop some very highly specific treatments to anemia of inflammation, we may be able to answer that question. So I will come back with one more episode on anemia of inflammation, talk a little bit about treatment, a little bit more about identifying what is anemia of inflammation versus iron deficiency versus both. And this is Dr. Gil Perrott, and I will catch you on the next round.